So we are in last section of chapter 7 in your biology book, and we're talking about muscles and how they react. And we got down to our nerve impulse reception. So muscles have to be triggered by something to react. Well, our body reacts with our different systems in our body. Our nervous system works well together with our muscle and skeletal system, moving our muscles. So nerves move muscles. So how do nerves move muscles? Well, the muscles triggered by the nervous system by what's called motor neurons. Neurons, of course, are nerves, and they transmit signals to our individual muscle cells. And so they signal. How do they signal? Well, at the neuromuscular junction here, and that word neuromuscular junction there is where it all happens. And the nerve triggers the muscle to contract by releasing a certain chemical called the neurotransmitter. And this chemical gives out electric signals to the muscle so that activate the muscle so the muscle will contract. How amazing is that? Here we have a picture of what I'm talking about here. So you see up here in the corner, we have the neuron, the basic neuron coming down with its dendrites and such coming down, the neuromuscular junction happening right here, just this little part, and we have these large muscle cells. And so at this junction, it gives off a chemical which electrically stimulates the muscle to contract. You can see here as the fingers of the neuron coming down here, and you can see down to this neuromuscular junction, down to this neuromuscular junction, and this one. So this one neuron here is affecting 1, 2, 3, maybe even more. 1, 2, 3, 4, 5, 6 muscular cells. So you can have one neuron affecting a multiple of muscle cells. So you can get precise control when it talks about precise control or control over many. So a single motor neuron, that's one nerve, one motor neuron can be attached to over 100 muscle cells. Can you believe that? And they all contract as one unit. How amazing. And we call this one unit a motor unit. The motor unit's pictured right here. This is the motor unit. All these motor cells together, muscle cells together, contracting at once is a motor unit. And going on to the precision, because the fewer muscle cells that are attached to each neuron gives us a more precise. Like, okay, they say your larynx. Take your larynx. Your larynx is your voice box. It needs to be pretty precise to give the different tones of voice, doesn't it? So basically, you have one neuron just with 3 motor cells. That's not very much, with one neuron going to 3 motor neurons. But your neurons in your legs and your abdomen, they have one neuron that causes 400 muscle units to go at once together. Because your muscles in your stomach are not that precise, are there? And then of course there's dexterity, the very dexterity you need maybe in your eyes. The neuron with very few muscle cells. So the more precise, the less muscles will be attached to that neuron. I hope you understand that. And of course we have what's called here, and it's called the all or none principle. That's pretty important, because the all and none principle says that once the muscle contracts, all of the muscles of that unit will contract. And they always contract, and then they relax completely. So they never expand. Let's just say that. They always contract and then they relax, okay? So make sure you have that all or none principle. When a muscle fiber is stimulated to contract, it does so completely and then relaxes completely until another nerve impulse pulse reaches this. This is the all or none principle of muscle contraction. Slow, steady body movements are accomplished as motor neurons within a muscle stimulate particle motor units to contract and allow others to relax. I just read that from your. So let's go over this last section and then we'll be finished. And this talks about muscles' strength and weaknesses. So this we've gone over before, so I'm going to go over quickly. We're going to talk about two different strengths, let's say, of the muscle, how the muscle can get. So the muscle is either hypertrophy or atrophy. Hypertrophy is basically where it's more efficient with use. So enlargement of the muscles is hypertrophy. Hyper means muscles getting bigger, right? How do you make your muscles bigger? Exercise, yes, exercise through use. And muscles can shrink through lack of use, called atrophy. Atrophy, they found that astronauts, when they go out in space, they have to do exercise because the gravity's not reacting on their muscles will start atrophying. So it's very important, if you were out in outer space, to exercise. Well, even today, if you don't exercise, your bones and your muscles both will atrophy, right? Especially your muscles. So atrophy just means that the muscles will degenerate through lack of use. So skeletal muscles must be used or they will atrophy. If you have a cast where your muscles can't move for a long time, those muscles will start atrophying. So it's how important. And then it talks about something about red and white fibers. What are they talking about? So, well, all muscles have mitochondria in it. And red fibers, because they're red, have many mitochondria in their myoglobin, many fibers. So, but the red fibers, they have myoglobin and many fibers, but they react slower than the white fibers. You would think because they had so many mitochondria, it'd be different. But the white fibers have fewer mitochondria, but they have to react quickly. And when they react quick, they're like all of none. They're called fast twitch. So if you have to find out about the white fibers and the red fibers are the slow twitch. They react slower for longer periods of time, and they have greater endurance. The red fibers have greater endurance with exercise and such. And the white fibers are the fast twitch. So you don't really need as many white fibers. White fibers are in emergency situations. So when you have to use a lot of energy at once and they run out of energy very fast. So it's like the flight or fight motion. All of a sudden your adrenaline comes and uses up all your white fibers because they're the fast twitch fibers. And the red fibers are the slower, more enduring. And the red fibers have lots of mitochondria to get them through long periods of time. Most of our muscles are a mixture of red fibers and white fibers. So it's important because they have the white fibers to react quickly and for emergencies, and they have the red fibers that go on over the power plants of long periods of time. So exercise. So basically they're telling us here, and what you should know, that exercise stimulates the development of your muscles. So if you exercise, you are going to develop your muscles because it provides more blood vessels to your muscles, and also the proper nutrition is important too with the exercise, and getting the proper nutrition so that it will help you to move better and feel better all the way throughout your body. In the muscular sense, which reacts with your nerves and digestive system, it all reacts together as a functioning unit. All of our systems function together as we are this organism of a human being with 11 systems functioning so that we can be healthy. So one important thing about muscles, that talked here, and I think it's really important, is there's certain kind of vitamins that are so important, but calcium is one of the most important. If you are defunct at calcium, you're going to have muscle cramps, you're going to have problems in your muscles, because muscles really need calcium to contract. So it's important to have a lot of calcium in your diet. The last thing they talk about here is muscle sense. Muscle sense is just the awareness of your body movements, and it comes from your nervous system, which is basically in your brain. So, and it's another striking example of God's marvelous design and precision engineering of the human body, that your muscle sense, the awareness of your body movements, goes, the nerves send to your brain and says, oh, your body's moving, your arms are moving, your legs are moving. How important that we are indeed fearfully and wonderfully made. So that is, we'll be going on to the chapter review, and then we'll be done with chapter 7, which has to do with your bones, skeletal system, and your muscles, muscular system. And then we'll go on to the nervous system.